Hello, everyone. Welcome to Rational Science, the only site on the internet that does physics rationally. Everybody else does mathematics. They move concepts around. Well, I'm going to be answering some questions at the end of the lecture, and we're going to have a lecture on wave function, including the wave function collapse, whatever those things are. But let's begin with some of the subjects related to extinction. And what is all that about? Well, here we argue that we are the last generation of humans on Earth, and therefore we don't have too long to go. Personally, I doubt we'll ever get past the 21st century. Okay, that's my take on that. I can't give you a date. All I'm saying is that when the global economy collapses, it's not an if, it's a when, it's the end of man. Okay? It's going to be the collapse of the economy that's going to kill us. No asteroid, no diseases, no climate change, none of that nonsense. The global economy will collapse when it does, not if, but when. It's the end of man. And that's a long story. Not going to cover that today, but you can ask if you're interested. Anyways, a bit of news here came out. Went on the other side. Give me a second here. Where'd it go? Here it is. And it says divers in Taiwan film rare encounter with giant what? Doomsday fish believed to be a harbinger of earthquakes. I don't know if it's a harbinger of earthquakes. I would say more or less that it's a harbinger that we're the last humans on Earth. If there's a doomsday fish, someone prepared out there, it's got to do with us. Okay, we're the last humans on Earth. So I don't know about doomsday fish, but it's a good icon. Pet. What is it? Put on the milk cartons, saying that we're the last humans on Earth. Anyways, here's another group, and they say that they're looking for extraterrestrial intelligence. I guess they can't find it in Cambridge or in Harvard, and that's why they're looking outside of the Earth. But the issue here is that these people say we have to watch out for what we stare out there because we might find what we ain't looking for. In fact, if the other folk discover that we're spying on them and it turns out that they didn't give us any permission to spy on them, then in that case, they might get angry and colonize us and treat us like Columbus treated the Indians. And here's a bit of news. It says, first contact with aliens could easily end in genocide, scholars warn. And they say this is probably the year of the alien contact. And the reason they say that is that there's some news lately on UFOs, unidentified flying objects, right? President Biden gave orders to shoot down 3 UFOs, leaked footage from a Navy pilot of a UFO that came out in the news recently. Whistleblowers report on U.S. government cover-up about UFO research. And a lot of people claim that the United States agencies, some of them out there, have collected clandestinely some UFOs or parts or whatever. And so you constantly see this in the news lately. The question is if there's some politics behind it, you know. Anyways, what do these people say? Well, by the way, this comes from the SETI research in Berkeley. Okay, SETI means Search for Extraterrestrial Intelligence, and the investigators they say, are virtually mainly people from science, technology, engineering, and math. And there's few people from the social sciences. And they say if ever you have the extraterrestrials come over here. The question is whether you want to meet them with, military brass or whether you want to meet them with some people with more social skills, we could say, or humanities. Um, Anyway, it says if humans are perceived as disrespectful, ET contact could more likely lead to their colonization of us. And I think they're thinking something along the lines of Columbus. There you see the on the right hand side the ETs coming to visit us backward folk, right? We're trying to buy them with some beads or whatever. And then there's an example there where the Royal Society told James Cook, to avoid colonization and, hurting the natives, that kind of thing. Royal Society being the scientific branch, right? But there were private investors who had other ideas and who funded the trip, and they suggested that maybe, just maybe, they could conquer some of the land out there. So the point is, who do you want to represent Earth? Would you want military, business people who are the ones who are running, a lot of this extraterrestrial rockets and so on? Or do you want people like, from the humanities, people that have more social skills, doing or entering at least the business and being invited so that they can counsel from another point of view, right? And the issue here is that I don't know what all these people are up to, but it's never going to happen. We're never going to see an alien, an ET, right, from outside the Earth here on Earth. It can't happen. One, because we're going extinct, but besides that, it's impossible for life, for anything living, to travel interstellarly. Okay, so that's the argument we have here, and I've talked about that in the past. Okay, one fellow says, the phone says, you once replied to the assumption that vaccines cause autism, saying that those espousing this are plain politics. The idea that autism is due to lack of genetic diversity, how is this not also plain politics? Well, I justified my stuff, and I don't think it's got anything to do with politics. Okay, here you see Calhoun's mice, and he built an enclosure and fed these mice everything they wanted. He started out with 4 couples, ended up with all those mice that you see there. 2,200, I think, was the highest number. And towards the end, he created or mice were born that were autistic, and some of them were homosexual. I say that Calhoun created homosexuality in the lab, one of the first ones, if not the first one, and with animals. So these are things you got to look at, and this is not plain politics. Here you have his results, more or less. Started out with 4 couples. Mice went up to, what was it, about 2,200, I think, or 2,000 thereabouts. And then the colony went down. They stopped reproducing. A lot of them lost interest in sex. They stopped having relations with the females. The females became aggressive. Okay, and a lot of the mice that were born with mental problems. And so sounds like, the society we live in today. And that's more or less what Calhoun was saying about this whole thing, right? So, that's not politics. What it is I'm giving you some facts. You take them for what you want. But all I can tell you is that experiment reflects humanity quite well, in the sense that we moved to the cities. Cities are ultra crowded, and majority of the people have moved to the cities and are in the process of moving still further into the cities in every country of the world. When they get there, they stop having kids. They go nuts. They can't find jobs. They're excited, right? Women are becoming more masculine. Men are becoming more feminine, etc. So there's a lot going on that, at least for the purposes of population, it's a negative trend. All those are negative trends. Okay? And so that's essentially, what we refer to here, what we're talking about here. fellow says, or someone says here, says, loss of genetic diversity is due to mixed relationships among races. That's a catastrophe for humanity. Okay. What can I tell you? Maybe one of the questions this fellow should ask himself, and anyone who thinks like him, is, um, have people who are white marrying white, yellow marrying yellow, black marrying black, do they have problems even though they've never mixed with any other races? Don't they have autism and genetic diversity problems and all this other stuff? I mean, to say that this was caused by mixture of races sounds very political and very little scientific. Okay. Yeah, you can hold any opinion you want. The issue is justifying it. Okay, one fellow says that on August 25, the EU shuts down the internet. No joke, internet doomsday is coming. Digital Service Act, all opinions, all channels, and sites that don't conform to the mainstream are censored or have to be deleted. Free opinions no longer exist. Okay, thank God they give us a month to get to reach there. Okay, what does this fellow say? He said, well, I looked it up, Digital Markets Act, and it says the new rules will also help protect users from harmful and illegal content. Aha, and this comes from the European Parliament, by the way, okay? So yeah, they are protecting you, okay? They will significantly improve the removal of illegal content, okay? So you got to watch out what kind of content you put up there. Especially, it says, it will also help tackle harmful content, which like political or health-related disinformation. Political or health-related disinformation. Sounds like that fella I had the other day, right? David, whatever his last name was. Doesn't have to be illegal and introduce better rules for the protection of freedom of speech. So now these folks are protecting your freedom of speech. That's what they're doing, can't you see? And so they don't want you to disinform the public on political or health-related issues. Okay. So anything else you can talk about? Why don't you talk about Hollywood and the girls out there, how great they look? Talk about stuff like that, important stuff. don't, don't talk about politics and don't talk about, health issues, especially about COVID. None of that. Don't touch it. I found out the hard way. They gave me not a strike, but they gave me a warning. I had no clue whatsoever. Okay, finally, the fellow says, with the Oppenheimer movie coming out, can you explain nuclear weapons and what we are told radiation is? Why are Nagasaki and Hiroshima habitable? Well, all I can tell you is my take on this is I agree with the establishment of quantum mechanics as far as, the chain reaction. Okay, you have the explosion essentially of the uranium atom. And uranium has, 92 protons and electrons supposedly, right? And 235, 238 neutrons. And think of it as 92, at least 92 or more hydrogen atoms stuffed together, crunched together, in a relatively small space. Obviously, it's the biggest atom. And you're going to break that apart. And so that triggers a chain reaction where it breaks other atoms apart and other atoms apart. And it's a quick thing that happens there. And that part I have no problem with. I have a problem with the part on the bottom with the so-called radiation. Okay. They simulate it with waves. And what are waves? Vectors. So you have all these moving vectors. What's a vector? Magnitude and direction. Officially, right? I say it's got no direction, but that's irrelevant for this discussion. What you're seeing there, that thing that's moving across, all those so-called waves, transverse waves, what you're looking at is numbers. That's what's moving. And so there's no such thing as a wave, especially a wave of numbers. Okay, so that's where they fail, and they call that radiation, movement of numbers. And then the other one is particles is way at the bottom there, the red ones, right? And those are not really particles, not in quantum. The quantum particle is a number also. It's not the corpuscle, the classical corpuscle. So what you're staring at there is a one-way flow of vectors, numbers, and particles, which are also numbers, values. They're talking about energy bundles. They call them wave packets or energy packets, right? And what is energy? A number. So the problem is they don't have a physical interpretation, and we're going to be talking a little bit about that today as well. So the difference there is that radiation, according to us, is the torsion of physical objects that look like a rope. Okay, so it's a pair of twine threads. They twirl in situ, and that torsion goes in both directions. So we have a different version of what radiation is. And as far as Nagasaki, the two cities there in Japan, why is it habitable? Well, here, let me show you something. These are some of the explosions we had on Earth. We had a few more, obviously, but the first one was in 1945, and that was Alamogordo in New Mexico there. And if you go by there, like I have, I've gone through there, in fact, more than once, and I don't think I have any radiation. I think I'm okay, right? And certainly don't have cancer, not yet at least. 1979, we had 3 Mile Island disaster in, Pennsylvania. 1986, Chernobyl in Ukraine. And 2011, Fukushima in Japan. And these were close to small towns, and people were evacuated immediately after that, after the explosions or the accidents, right? And what happened after that? A lot of people came back. Many have settled back close to, where the accident took place, and it didn't do anything to them. They measure the radiation. I mean, radiation doesn't last forever. This notion that people have that once the bomb falls, the radiation lasts forever. No, it dissipates eventually, it dies down. And so you can go and live back there again. There's no reason to think that, once there's an accident or a bomb is deliberately thrown, that you can no longer ever again live there. Some people have moved back to Fukushima and to Chernobyl. They say that they, sent people to some other cities or some other city nearby. But I have doubts about that in great measure, because they mention a city that has 25,000, 26,000 inhabitants, and Chernobyl had 48, 49, almost 50, twice as much. And so I think some people live close to Chernobyl again. I just don't know, but I would think that it's not a ghost town completely. But for sure, 3 Mile Island, nobody, left the country because of that. And same with Fukushima there. These are accidents that happen, and the radiation eventually dies down. So there's no reason not to live there. Okay, I think we should worry more about some politicians out there deciding to throw the bomb again. Now that's something you should worry about. If things come to a point where conventional weaponry doesn't do the trick, they might decide to press those red buttons, and it's more than just a threat. It could be a reality. And when that happens, which would be if it happens, in that case it's an if, because it doesn't mean we will throw those bombs, right? But if that ever happens, it's because the global economy is in big trouble. So it's triggered by the global economy, competition among countries, etc. So it's part of the theory that I have. In other words, I'm saying the global economy is going to cause the extinction of man, but that doesn't rule out that at the last moment people start pressing those red buttons. Okay, let's move on to the subject matter today, which is what? It's the wave function. Okay. Now, I need to give a little preamble here, a little introduction, right? And it's that, if you look at mathematical physics today, it's in bad shape. it's in bad shape because people have reached a point where they can't answer any questions, none, and all they can say is we're investigating. We don't know, but we're investigating, and that's so exciting because science is like that. It's investigating forever and never finding anything, right? The idea is to investigate only, research, job security, not to really find. And they can't find. It's impossible for them to find because they've gone off on a tangent. They're not doing physics, they're doing what abstracism, instead of physics, they're doing the opposite, exactly the opposite. They're working on abstractions. And the question is, how did we end up like this? Well, it started with some of the people like Galileo. Okay, Galileo had in his book, he wrote the following. He says, philosophy, meaning natural philosophy, right? That's what they called science in those days, is written in the great book whichever is before our eyes. I mean, the universe. But we cannot understand it if we do not first learn what the language and grasp the symbols in which it is written, which is the book is written in mathematical language. Okay? And then he goes on saying mathematics is the language in which God has written the universe. And believe me, if I were again beginning my studies, I should follow the advice of Plato and start with mathematics. And he came at the heels of people who were doing experiments like Gilbert and Stebbins and Moletti, people who had already done the experiments that today we attribute to him. Throwing two weights and discovering two different weights and discovering that the lighter one does, or the heavier one doesn't reach the floor before the lighter one. Okay, and that was done by Stebbins already in the 16th century, not 17th, which is where he wrote this his book. Galileo wrote his book. It already happened in the 16th century. Moletti talked about it in the 16th century when Galileo was still wearing shorts, running the streets as a boy. So they already had the idea of experiments, and then they started putting math behind that. And today we have math and experiments, and that's more or less the notion that the mathematicians have today, who call themselves mathematical physicists. They're not physicists, they're just mathematicians with irrational explanations for anything that's invisible and intangible. Okay? And so one fellow kind of summarizes my way of thinking here. He's pretty close to how I think, and he says the following: like I told you before, Bill, physics is math ever since it's been divorced from natural philosophy. Physics is not going to give you the answers you're looking for because it doesn't give a damn. Its sole purpose is to exploit and reproduce natural phenomena for technological purposes, for its ultimate goal of making money and win Nobel Prizes. Everything they do must have a practical application. Okay? Experiments, right? Or nobody cares. Green, Tyson, Cox, Caro, Kaku haven't done physics in decades. Like you said, they're clowns. Yeah, these people are more than they're clowns in the sense that they're in the entertainment business. They're not into physics or science. And here you have an example. Everybody knows Tyson there, and he puts out a quote, and just about everybody on earth quoted him. Repeated his quote: "The universe is under no obligation to make sense to you." I mean, you'll find hundreds of these. And, they listen to this guy, and what is he saying? He's saying, look, we don't understand the universe. That's essentially what he's saying. He's just twisted around and says, hey, Father Universe doesn't have to speak the same language you do. That's a way of twisting the ignorance that he's confessing there, okay? And so you look up Tyson, you look at what he does today, and he's in an entertainment business. You would think he's a physicist, and he talks about, do we have free will? He's he's in subject matter that you would say, is he an expert on free will, on religion, or any of that? Why is he talking about free will when he should maybe be talking about physics? or how does a magnet attract another, or stuff of that nature, or even cosmic stuff. And the question here is the following. These people will tell you that when you say, look, how does a magnet attract another? And they say, well, that's not a question of physics, it's a question of philosophy. And when does this pencil fall to the floor? Well, that's a question of philosophy. The mechanisms, they say, the explanations, the whys, the causes, those are regarded as philosophy. But this fellow then goes in there and talks about what? Free will? That's not philosophy? I mean, you would think that, what's that got to do with physics? Okay, so if that's part of physics, if that's part of what he can talk about, why doesn't he talk a little bit more about mechanisms, But no, they dismiss that as philosophy. Okay, and here's one guy that says it's straightforward to you, so that if you have any doubts, he'll tell you exactly how much all these people know. His name is Sean Carroll, and he was interviewed, and this is what he has to say after a while, right? He says, "We just don't know." That's the best answer they can give you. And just in case you're ready for another question, he says, "Hey, so that is not a good question to ask." These are the exact words that come out of his mouth. Say they don't know, and they don't want to answer certain questions, especially related to explanations, to mechanisms, to whys, to causes. They don't answer those questions. So the question is, what do they know? And they have this duality, or this, they cover both bases. On the one hand, they say, we don't know anything, don't ask us because we're still researching and we don't know that question. Don't ask that other question, blah, blah, blah. And on the other hand, they say, oh, we know everything. We've proven everything. We've proven quantum mechanics. We've proven general relativity, string theory, and who knows what else. They've proven everything. They've proven Big Bang. You can't even contest that. They've proven, black holes, dark matter, dark energy. All's been proven. It's already settled. And when you ask them, how does this work? They say, we don't know. Don't ask us. We're still investigating. So we have a contradiction, because on the one hand, they say they know everything. On the other, they say they know nothing. Okay, and this is where the problem is. And the question is, do they know anything? Okay, this is what. So yeah, this is what I said the other day. The circus is in town. All these people are clowns. They're stand-up comedians, vaudeville comedians. Why? Because they're in the entertainment business. They don't know anything about physics. They cannot tell you anything about physics. And they get millions of hits in all their videos, and they're very popular. I'm sure they get a lot of money for what they do. They're called to give talks, etc. And what do they talk about? All they can tell you is that they don't know. And so why did you pay, whatever, $50 to go see them just for the celebrity issue? So no, none of these guys know anything. And so you're wasting your time when you go and visit them, whether you visit them in person or you watch their videos or interviews or whatever, or a show where they're in. These people don't know anything, especially they don't know anything about science. But a lot of people have this idea that, they're getting their shot of science for the week. Oh, I'm going to listen to Brian Greene or Brian Cox or, Tyson or who knows. And they think they're getting their shot of science. They sign them. They follow these guys. And it turns out all they're given is nonsense. These people cannot talk to the public about math. They cannot go in there and begin talking about equations, because people will just leave. So they have to kind of translate the equations to what people might understand. But when they translate, they only translate nonsense, which is the only part that they can talk about on TV or in movies or wherever, in interviews. They can only talk about the physical interpretation, okay, of their equation. Because, otherwise people will be turned off. They don't understand all those equations. So they give you the most irrational thing they can give you. They ask them, well, that doesn't make sense. Yeah, we don't understand it either. So what have you learned listening to those people? It's like you grow dumber by the second than for every word that comes out of their mouth. And so, yeah, we have some people who are questioning some of these things, and they say the following says, looks like we are at the end of physics. And another fellow says there, he says, the next few years may tell us whether we'll be facing questions that we cannot answer. Everybody is more or less, or not everybody, but a lot of people are coming to their sense and say, hey, you know, there's something wrong. Is it the end of physics? And the answer is no, it's not the end of physics, okay? Let's get that right. It's the end of mathematical physics. Okay? Mathematical physics is not physics. It's the end of mathematical physics because with all the equations, all the experiments, all the measurements that they have done, at least in the last 100 years, if not the last 400 years since the so-called scientific revolution, you know, we made no progress. These people don't know what electricity is. They say it's a flow of beads, but what are they using? The planetary model of the atom, which they deny. They say, well, that's not the Bohr's model is not true. They don't know what magnetism is. They don't know how a magnet attracts another. They can't tell you how gravity works. You know, simple thing. You know, my great experiment. You know, we have a pencil. Very important thing. Very always do it in the presence of a relativist, right? Never do it on your own. Okay. You let go of the pencil, and it always falls to the floor. Okay. And they cannot explain why a pencil falls to the floor. They go through this whole thing where, you know, they have to bend space, time, and time, you know, they bend time, like if that's a mechanism, a physical interpretation. So, yeah, they have no answers for anything that is invisible and intangible. That's what they haven't figured out. And what they haven't really figured out is they have to, you know, imagine what Mother Nature is using as a mediator. That never crossed their mind. They think that because, you know, they can't see or touch something underneath a pencil or above the pencil, that there's nothing there. And so they go into concepts and say, well, it was mass, it was gravity, it was energy, force, you know, time. Okay, so let's find out what this wave function is. Let's start with some definitions. And a good way of looking at this is through the universal movie. You know, I like to do it through the universal movie. What is the universal movie? Real quickly, every frame represents location. Location of every atom in the universe. Therefore, there's nothing moving within any frame. If you want to see something moving, you will have to use at least two frames. That means the ones on the bottom, for example, are those that require at least two frames. The ones on the top, the concepts there, or objects, right, they only require one frame of the film. It's like if you had God's camera, you took a picture, a 3D picture, right, and that's what you put in a single frame. Everything's just standing still at a given distance from everything else. Okay, that's it. And where do we put the wave? Well, a wave is not a physical object. It's not a thing. We cannot put it on the top. We cannot put wave in a single frame of the movie. Wave requires at least two frames, partly because it's made of what? Two fields. Okay, you have the electric field and the magnetic field, and here we're talking about the light waves, right? Wave of light, right? Electromagnetic waves. So you have electricity and or electric field and magnetic field. You need two waves, and then just in case you have to put, you know, if you're going to put the wave, you're going to need at least two frames. It's going to stretch across two frames. You cannot have the word wave in a single frame. Okay, so that's what the problem is. You know, so wave is a dynamic concept, and it's not a physical entity, which is what mathematical physics uses it as. Okay, they use it as as if it were a physical object, and that's where they fail. Okay, so you cannot say that the wave did this, the wave did that, because wave is not a thing. Okay, you cannot use it as a noun in physics. Okay, you can say the flag waved, you can say the water waved. You cannot say that the wave waved. Okay, wave is a verb. It's not a thing. Okay. Okay, so that's the wave. How about the function? You know, remember we're talking about wave function. Here's a function. Function is essentially an equation, even though there's a little bit of a difference. If you look at a function versus an equation, you can see that are just slight differences. Two or more variables is what a function has. You don't need variables in the case of equations. And you can write the function as an equation, right? And the equation may or may not be a function necessarily. Okay, so you have these couple differences between them, but essentially you can think of a function as an equation, okay, for all practical purposes. It's just a fine print, okay? So there you have a function. Why did I put it on the bottom? Because a function, an equation, represents motion, always, okay? Always is, it's what it is, okay? A function represents motion. The way you do motion is you have to replace values inside the variables, okay? So you have a variable, you replace that with numbers, and for every number you put in, you get a result, and you plot those results, and then you have your motion. You have the universal frame, universal movie, with each frame representing a single, location. Essentially, that's what you get. So function is dynamic, wave is dynamic, so we have a wave function. What do you think it is? It's a dynamic concept. It's not a physical object. Guess what? They treat it as a physical object. Wave function is like a standalone thing. That's the way they look at it. And here you have the source of the wave function. It's Mr. Schrodinger, Erwin Schrodinger. And it looks like that thing up there, okay? And what does it represent? We're not here to do math. We're here just to say that, you can calculate the probability of finding a quantum particle in a given state by treating it as a what? A wave function, okay? So all you got to do is replace some of those variables there, and you'll have your wave function. Okay, great. So what does that wave equation do for us? I mean, apparently it just describes, you could say, motion. That's all we're doing there, okay? Nothing more than that. Okay, so this is what it looks like once you put it in motion. Okay, this is going to be the wave function in motion. This is the universal wave function in motion. Okay, it looks something like this. Okay, you can see it there. It's like a little snake rolling around a wire, a pipe. Okay, that's what it looks like. I prefer to look at it a little differently, and more or less like that. That's what they're talking about when they're saying the universal wave function. Okay, I mean, you would think that this wave function covers the entire universe, right? Because this is what they're referring to. They're saying the wave function is the entire universe. In fact, here you have one fellow who put them together. His name is Roger Penrose. And he made the wave packet. He puts that in his book. He illustrates it like that, like you see it there. And I guess it comes from the wave and the packet. They put them together. And that's more or less what Schrodinger worked with to get his notion of the wave equation, or the universal wave function. Okay. In those days, I think they just applied it to the particles, to a given particle, but today they have extrapolated to the whole universe. And here you have one guy who vouches for that. Okay, he'll tell it to you in his own words. Okay, here's Sean Carroll, and he says the universe is a quantum mechanical wave function, and that is all that exists. He was interviewed by Closer to Truth fellow. Okay, the same quantum thing can be sliced in different ways to give different objects, tables and chairs and peoples and planets. Okay, so we have a single wave function, a universal wave function. You slice it in different ways to give it all these objects that we can see and touch on every, here on Earth. Okay, great. So the interviewer asked, what does that literally mean? Yeah, I mean, what have you said? A quantum waveform of the universe? Is it one big thing that describes everything, or is it one big thing that has little quantum waveforms that comes out of it? In other words, is it chopped into pieces, or is it a single thing made of a single piece or whatever? Can you chop this thing into pieces? And the answer is, it's both. That's the kind of answers a mathematical physicist would give you, right? It's both. It's both at once. That's the miracle of applying quantum mechanics. He even, comes on top and he says, hey, that's a miracle of quantum mechanics, One of the things that makes it difficult to understand, there aren't separate quantum wave functions for different parts of the universe. In quantum mechanics, there is not a wave function of the baseball and a wave function of the bat. There's a wave function for the baseball plus bat system. In fact, there is one wave function for the entire universe all at once. So how does he, reconcile this with tables, chairs, peoples, and planet? I mean, here you have a little bit of a problem because he says there's a single wave function, and then he says that you can break it up into little pieces. So which is it, A or B? And again, he says it's both. Okay, and so what have you learned? Nothing, absolutely nothing from this fellow. And here you see, he continues, he says, what really is happening is this abstract mathematical thing, the wave function. Yeah, it's a happening of this thing, he calls it, but it's a mathematical thing. It's an abstract mathematical thing, the wave function. Okay, what is he talking about? And he says, we even have a name for where the wave function lives. So not only do we have a thing, but it lives somewhere. It lives in a space called Hilbert space. Hilbert space is just an enormous space of possible wave functions. Oh man, we're learning so much from this guy. Okay, it says a wave function just evolves in Hilbert space. That's all there is. This wave function evolving in time. There's no extra explanatory level. So don't expect a physical interpretation beyond that. He's told you everything he knows. Okay, and when we talk about reasons and causes and explanations, which is what physics wants to know, laymen also want to know that, these are ancient words that we repurpose. Maybe they just don't apply in modern quantum mechanics. Yeah, they don't apply because not a single person in quantum mechanics can explain causes. Reasons don't belong to physics, but causes. Mechanisms. That's what they cannot explain. And so why? Because they've never figured out the invisible stuff that Mother Nature uses as mediators. That's the problem. They've always used particles, and they converted the particle into a number, so we don't even have particles anymore. Corpuscles, classical corpuscles. They illustrate a little dot, a corpuscle, but when you put them against the wall, they say, oh, but we don't mean that. What you're looking at is a bundle of energy. And what is energy? A number with a unit, right? Okay, well, he should have paid attention to another fellow known as Richard Feynman. And if he would have listened to Richard Feynman, he wouldn't be saying nonsense today. Here's Richard. He says, you think I'm going to explain it to you so you can understand it? He was talking to students. No, you're not going to be able to understand it. You see, my physics students don't understand it either. That is because I don't understand it. Nobody does. While I am describing to you how nature works, you won't understand why nature works that way. And then in another class, he said the following, which I think is even more famous. He says, I think I can safely say that nobody understands quantum mechanics. Do not keep asking yourself if you can possibly avoid it. But how can it be like that? Nobody knows how it can be like that. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. Okay? So what's the issue? The issue is quantum mechanics, or you can say mathematical physics and mathematical physicists. They've given up on giving you explanations, physical interpretations. They've dismissed that now as philosophy. They say, well, that's just philosophy, ontology, word salad, semantics, right? They don't care about any of that. They care about what was Tyson about free will. That's the stuff, And this guy also talks about how the brain works. So did Roger Penrose, by the way. They went into philosophy, what is known as philosophy, why you think the way you think, this kind of stuff, which has very little to do with physics proper, right? Okay, so we're in the wrong subject matter with quantum mechanics and with mathematical physics completely, all around. Here is what the what they do with a wave. They say that if you observe the wave, this great wave function, right? If you observe it, it collapses to a point, essentially. So it's spread out when it's not observed, and when it's observed or touched or whatever, it collapses, okay, to a point. And so I like to illustrate a little differently. Here you have, you're going to be sticking your hand where the wave is rolling, and suddenly when you go and touch it, it turns into a ball. That's essentially what quantum is saying. They never explain the mechanism. They just say, this is so, we proved it, it's a done deal, and we cannot explain it. Of course they cannot explain it because they're doing more magic than the Bible. I mean, here you're talking about not Jesus walking on water or going to heaven and coming back after 3 days. None of that stuff. That's easy stuff. But this stuff, it's even unimaginable. You cannot imagine this stuff. They're saying that here you have a wave, which is vectors, right? Moving vectors, which is already irrational. And as soon as you touch those vectors, it turns into a ball. And the ball is not a ball because it's a quantum number. It's a value. So all they did was transform, vectors into a single value. What does that mean? What does that have to do with physics? That's the question. It has nothing to do with physics. Certainly nobody cares about that stuff. People want to know why a pencil falls to the floor, how a magnet attracts another, what is electricity, how does the atom really work, what does it look like? Okay, that's what the people want to know. Okay, so here's the universal wave function, and this is what happens when it collapses. Here, you'll see it in a second. Here's the wave function, universal one, right? And suddenly, it goes in there and kaboom, collapses to a point. So that's what we have. And so the question is whether, this is more or less what we saw the other day with the two black holes rolling around each other. It's moving all those waves that they claim they were able to sense, detect. And the question is that the wave function that they're moving there? Are those ripples along the wave function? Is that the material that is waving, the wave function? So we have a big problem because we reached, after 100 years of quantum mechanics and relativity, fewer 50 years maybe or less than string theory, right? What do they know? What do these people know? What are they talking about? They're talking about wave functions. That the universe, the entire universe, is no longer space and stars, and planets and that kind of stuff. No, it's a wave function. And there are localized, I guess, wave functions that turn into planets, stars, and whatever. And these people say, well, that's just an interpretation because it's really a single wave function for the whole universe. Then they tell you the wave function can collapse if you observe or touch it, right? See or touch, right? And so here's the universal wave function. It's a single wave function. I hope it doesn't collapse every time I move. I touch something, I see something, the entire universe collapses. The wave function of the whole universe collapses. What sense does any of that make anymore? I mean, these people were completely out of it. That's why they had to get into what? In the end, into the entertainment business. That's why they had to be clowns, because they're interested in making money, saying, look, I studied 10 years math at the university. I want to make money off of this. And they can't make money explaining how the universe works, so they don't do science or physics. What they do is they say, let me tell you what we understand. And we don't understand anything, but this is what we understand and that we have proven. And they talk about black holes, dark matter, Big Bang, all that stuff, particle being at two places at once, all the good stuff, entanglement, this particle affects that one by magic, instantaneously, all that good stuff. And then they tell you all this stuff and you say, but all that is irrational. Yeah, we don't understand it either, but we've proven it. That's important. We've proven it. Okay, so yeah, what can we say? Here's some of the issues that people ask, questions, comments people made. I'm going to start with one thing I was looking at the other day, and it's this. They have a black hole laboratory at Nottingham University. That's where Robin Hood went, okay, Nottingham University. And so today they have a black hole laboratory. I was I was really stunned by that. They even have a special place for black holes. Okay, maybe it's that Hilbert space that's in there. I don't know. The black hole is occupying somehow. Okay, a fellow says the universe is both one universe multidimensional. Well, yeah, they like to cover all bases. See, you got to do a little better than that. I explained the other day that you could have all the galaxies in the universe. Uh, they could form a single universe because they all share the same space. The question is whether there's another group that is separated from our group. And we'll call that temporarily, we'll call that a second universe, a parallel universe, another universe. The problem with that idea is that you cannot separate one universe from the other because you cannot put a fence to space. That's where the problem is. You know, for example, here you have the multi-universe, right? All those W maps there, okay? So our universe is one of those, right? And there's all these other universes. What's the problem? The problem is that each one of those universes contains the black stuff that you see there, contains space, and it's the same space as ours. In other words, you cannot put a fence around space and separate it from that other universe. So the question is, universe, there's only one, because space you cannot put a fence to space and somehow separate it from another universe. All matter in the universe shares the same space. Now, could there be a different clump of matter separate from the clump of matter where our galaxies and stars and everything here is? Yeah, that could be so, but then we can't call that a universe. We would have to invent a new word such as clump or whatever. That's the one I use. Clump of matter, okay, because that's what it is. Okay, so yeah, there's only one universe, but not multi-universes. Multi-universes, no, maybe multi-clumps. That could be it. Okay. Okay. Another person says, "What if God is universe himself?" Okay. Why cannot universe be infinite and eternal? Well, first of all, I think God would like to commit suicide, or maybe has already. I don't think he wants to live forever. It's the worst punishment someone can have. Imagine living forever and not being able to die. That's got to be terrible. I think it's a curse, not a blessing. I mean, it'd be nice to live maybe 200, 500 years, that's fine. But to live forever and not be able to die, killing yourself, stabbing yourself, poisoning yourself, yeah, so God probably committed suicide by now. But the question here is that, I haven't answered the question. You said, if God is universe. Yeah, if God is everything, which is the word that people use for universe, if God is everything, then God is nothing as well. What do you mean by God is universe? Okay. And then the words infinite and eternal are usually used to stop any questions. Because you say, well, I don't know, because he's infinite and eternal, and we have no clue what that is. So it's a way of stopping questions whenever you use the word infinite or eternal or forever, any of those. So, all you're doing is avoiding answering the question. You say, I'm not going to deal with the question. This is what I believe, and this is the end of the discussion. That's all you're saying. Okay, you're not investigating to find out what this universe could be, or how it works, or whatever, right? This is the issue. You got to really tackle and not run away. And when people talk about infinities and eternity, they're running away. Okay? Unless you're talking about whether the universe itself is eternal, which it is, obviously. But that's just an issue of matter not being able to convert into space, or space converting into matter. That makes it eternal. Okay, fellow says, I call the black stuff hyperspace. Well, you can call the black stuff there, where the stars are, anything you want. You can call it Charlie if you want. I mean, the question is, what is the green stuff if space, or what you call it, hyperspace? Okay, so it's hyperspace. No problem. We'll call it hyperspace if you like that word better. So the black stuff there with all the little stars, that's hyperspace. And so the question is, can you put a fence around hyperspace? And if so, what's outside? What's the green stuff? That's what we want to know. So anyone who proposes anything other than space right? He wants to call it hyperspace. Okay, you can call it Charlie. You haven't said anything. You just named it. The question is there something outside of space? Is space a physical object? Does it have a border? Okay, if so, what's outside of it? What's the green stuff? Can you put a fence around space? Okay, so these are the issues that people do not answer. They elude them. They start putting names there. Saying I gave it a name, hyperspace. Okay, great. So we call it hyperspace now to make them happy. And we have a flat earther. Okay, it says, taking the fact that since I was 6, the idea of outer space has been force fed to me and many around the world. Why talk about these concepts to children as young as 6? You want to educate them, I guess, right? Why show a globe in the background of every TV show, episode of movie? Why use the word globe in everyday conversations on TV and articles? I guess you figured out where he's coming from, don't you? I and many have never been to outer space, okay? Neither have I, okay? Without visible spectrum of light in free space of the wandering stars, planets, and the sun, then how can we assume outer space ever existed? Well, you don't have to assume. You have to define the word exist, and then you'll know whether space exists or not, right? And you got to define space as well. So you just got to define these words. You want to know whether God exists? It's a cinch. Very easy. You just define the word exist. And then we'll know if God meets the definition or not. If God meets the definition, then he exists. If he doesn't exist. That's how simple it is. So if you want to know if space exists, very simple. Define exist and then define space or point to it or whatever, right? And then if space meets the definition of the word exist, it exists by definition. See how easy it is? So it's not a question of belief. It's not a question of, saying I'm going to memorize this or anything like that. It's just a question of definitions. Okay, a fellow says, can you please define your concept of separation? Because we say distance is separation, right? And, I don't know if this fellow is just an extreme devil's advocate. A lot of people do that, and nothing wrong with that, except that, when they go off on a tangent, they're just, getting entangled by themselves. Don't define every word we don't define every word in science, okay? And for this purpose, for separation, ordinary speech will do, just a notion. What are we talking about? Separation, non-occupying the same exact volume. That's the notion, okay, that we have of what separation is. So you don't need a fancy definition for the word separation. Separation is what you learned when you were a kid. I don't think you need a super duper definition for the word separation. Everybody understands separation because we're saying it's just whatever notion we have out there in ordinary speech. Okay? I don't think we need a scientific definition of the word separation. And distance separation means, they don't occupy the same volume. Maybe that's a definition that you could use. But that's the notion. And so I'm not sure why people raise questions other than, extreme devil's advocacy. Okay, and here we have another fellow, and he says the following. He says, it's just the amount of torsion. Is it just the amount of torsion applied to the rope between two atoms that explains the various spectrum of radiation light? Or does the length of any given rope between atoms also play a role in determining light spectra? And yeah, here I can show you with a graph what we're referring to, okay? Here's the visible spectrum. You can see it's a small portion of the entire spectrum right there at the top in the middle, okay? So that's the one in color. That's how thin the visible spectrum is of light. And there you have it expanded. It's zoomed in, and you can see that we have the red to the violet, okay? Infrared to ultraviolet. And the question here is, what are we going to simulate light with? Quantum mechanics likes to simulate it with balls, little points, dots, circles, whatever, and they call them wave packets. Sometimes they just say it's a photon, and the photon stands for a classical corpuscle in the eyes of many. And then they clarify, no, it's not a classical corpuscle. What we're talking about is a number, a value. energy, a packet of energy, a ball of energy. So they go back and forth, and you never learn, what a photon is. Is it a particle or ain't it? Which is it? And of course, they'll never clarify that. They also simulate it with waves, and we can discuss that a little bit. What you're looking at is vectors, okay? And they draw that ridiculous thing called a transverse wave, electromagnetic transverse wave. And what you're seeing there is just vectors, and they call them fields. What are fields? Well, two fields make a electromagnetic light, electromagnetism. So neither the balls nor the wave there represent physics. They have nothing to do with physics because neither of those are objects. They don't stand in for objects. The object is the one on the bottom, and it looks like a rope more or less. And what we're looking at there is two twine threads, and where the links are wide, or longer, you have you're in the red side of the spectrum, whereas where they're very close together, where you have very short links, you get into the violet region. And that's the way it goes essentially all the way to gamma rays to radio waves. That whole spectrum, you can look at it in the same way. Longer wavelengths, you go to the left. Shorter wavelengths, you go to the right. Okay. And what's important about this is the following. Let me show you another graph that synthesizes this. Okay. Keep that one in mind completely. Let me get rid of this one. And this is what it looks like. Okay. You have C equals frequency times wavelength. That is the equation of a rope, okay? Because frequency is the number of links, and wavelength is the link length, okay? The length of a link. And you can see there, you take any rope, like a two-strand rope, right? Like this one here. Let me see if I can move this out for a second. And because it's better maybe to see it here. And here you see, if you torque the rope, the links become shorter and there are more links. And if you untorque the rope, for the same amount of rope, right, you have longer links and you have fewer links. Okay, and so that's essentially what C equals frequency times wavelength represents. That is the equation of a rope, which is torquing, which is moving around. Okay, so C equals frequency times wavelength, C being 300,000 kilometers per second, which is the speed of light, is equal to, the inverse relation between frequency and wavelength. You raise one, you lower the other. That is the equation of a rope. It's not an equation of particles. It's not an equation of waves. And light travels both directions because of a rope, not as it is in quantum mechanics in one direction. It's just unidirectional. The reason you see me and I see you at the same time is we are connected by the same ropes, every one of our atoms in our body. And with